Welcome everybody. We hope everybody's had a great week at Spring One. So I know you all, some of y'all might be a little bit tired from the week, so we played a little music up front to try and liven you up. Welcome to Simple Data Movement Patterns, Legacy Application to Cloud Native Environment, and Apache Geode. My name is Jim Biedenbaugh. I've been with the Federation of EMC, VMware, and Pivotal since 2011. I'm based out of Tulsa, Oklahoma. I'm an advisory data solutions architect. We have with us also Zach.
Hey, I'm Zach Hansen. Been with Pivotal since 2015, same team.
So here's our safe harbor statement. We do present code here, so it's without warranty. We're going to put it out on GitHub. If you want it, you're welcome to it, but it's at risk, entirely up to you. So, Zach.
Yeah, so all right. So as we mentioned before, we're on the data transformation team at Pivotal. And as we go through our transformation process and as we do our jobs day in and day out, it's easy to get lost in the details and in the individual technologies. And we lose kind of the value of the customer and the value of what we're actually trying to build. So throughout this, and just like our friend, the Acme Corporation, who is trying to modernize their data infrastructure on the cloud, we may have some new domain-driven services, as there was a talk earlier today about that as well as also trying to support some legacy systems as well that may also use that data. So I also invite all of you to also think about where you are in your transformation journey as we move forward.
So we have a number of roadmap considerations out there, but we're only going to talk about two of them today. The first one is we're going to talk about our constraints and considerations, conditions surrounding the migration pathways. And the second thing we'll be talking about is what our actual goals are in all of this. So in talking about the constraints and conditions surrounding the migration pathway, the first thing we have to recognize is that there will be continued use of legacy data by back-end systems within the organization in many, many cases. Not always, but many, many cases we find that. We will find that some of the applications will exclusively use cloud data. This could especially include those greenfield applications that you might be deploying out there. And that some of them will be using legacy data. That may exclusively be using legacy data through some pathway, some framework or migration or some kind of point-to-point communications. And the third thing is that we do also recognize that we have had deployments in the field where we'll be using both cloud and legacy data in the applications that have been deployed. And then finally, we also recognize that some of the data that's on your legacy platforms, and this could be DB2, it could be Oracle, it could be MySQL, SQL Server, those are all what I would call legacy platforms. That's going to have to move to the cloud, and there are some considerations you have to think about when you're moving that data from those legacy platforms into your cloud. So let's take a look at the goals that we might consider here. So optimally, we'd like to move all of our operational data to the cloud. Why would that be? Well, it's closer to the application, so there's less latency concerns. There's also less concerns about the infrastructure in terms of doing network hops across the network from a cloud platform into some legacy platforms. The second thing is that we want to make sure that we are minimally, and this is very important, minimally invasive on the legacy domain code and data, because we want this to be a transparent transition. We don't want to see our users impacted, affected deeply by this implementation, so we have to keep that in consideration. And there's going to be a transition period. There's going to be a time when some of the data that you're using in the legacy systems is actually going to be shut off, and it's going to be a cutoff point, and you're not going to use it anymore. But that may vary from system to system. You may have multiple cloud apps that are out there. Some of them are using legacy data, some of them aren't. And so it should be configurable so that each application can determine when they want to turn off the pipeline from the legacy system. So today, we're going to talk about 4 of the common migration patterns that we've encountered. Now, there are a lot of patterns, and there's a lot of permutations on these patterns. Most of these patterns should be recognizable to you, but they're the ones that we've most commonly seen in the field when we do these. And we're going to talk about it in terms of business value, versus technical value. What business value does it bring versus what technical value does it bring to your organization? So the first thing we see oftentimes is a simple point-to-point socket communication. Now this could be any number of types of implementations. You could use Perl scripts with socket listeners. You could use any number of frameworks out there. You could be using JDBC to the legacy system. It's your choice. There's no right answer. It's whatever makes sense for your organization, okay? This is relatively easy to implement, but there are some considerations you have to think about in terms of the technical value of being able to do failover, disaster recovery, those types of things. That falls more on you more than anything. The second one we've seen commonly is our claim check pattern. This is where we have legacy data, and somehow, through whatever mechanisms you employ out there and implement, your cloud applications are going to be notified that there's some data that it needs to go pick up. Now, this could be anything. This could be files, blobs of data, any number of types of data that are out there. Whatever you do, please don't send 5 megabyte files through Rabbit or these kinds of places. That's, in my opinion, not an appropriate use of messaging, okay? And if that's the case, then a claim check pattern is very good. You send something over to the cloud app. You say, hey, I've got data that needs to be picked up. Go get it. The next pattern that we've seen more commonly implemented in this is our tightly coupled bus. Now, this one begins to leverage some of the frameworks that are out there, Kafka, RabbitMQ, any number of types of messaging frameworks that are available to you. The downfall, or not the downfall, but the thing to consider is that this cloud application over here is very tightly coupled to this message bus. So it's not a loosely coupled implementation, obviously by the name. So you have to keep that in consideration. When you want to start changing where you get your data from, think about that. Now, this also is one of those implementations that brings a lot of value to the organization because, especially for the business, because you can begin to manage things like persistence to queues, failover, disaster recovery. That's built into a lot of these frameworks that you don't have to worry about yourself if you were doing a simple point-to-point communication here. And then finally, and this is the one that we've seen implemented a lot, and that's our loosely coupled message bus. We take the data from our legacy system, we push it out to a message queue or bus or communication system of some type, RabbitMQ, Kafka. We'll push it over into a sink. It'll go over to our cloud apps. This sync, more times than not, can be a Spring Boot app with some APIs that are either going to notify or he's going to go grab the data. The cloud apps are going to go grab the data. Now, I show this arrow going down from here to here. There could actually be, in any number of these patterns, messages can flow both ways. The data ultimately would flow from the legacy system over to here, but there could be any number of communication pathways that you actually want to implement to try and go say to the legacy system, hey, go push this for me, okay? So it's more of a pull than a push. So today we do have a demo for you that we put together, and we're going to show you a number of technologies that we've used with this. But we're going to talk about the last example is the loosely coupled message bus. And the technologies we used here, RabbitMQ, we've used Java, Spring Boot, Pivotal Cloud Cache, Pivotal Platform. Now, both Zach and I are Gemfire Geode folks, and we also work within the Pivotal Cloud Cache community as well. So it was a pretty easy choice for us on that one. Whoops, did I miss it? No, I didn't. The code. So the next thing we'll be talking about is the code that we actually use to implement this. Now, we're not going to show you all the surrounding business logic code and everything else. What we're going to show you today is what you need to wire it all up. So it'll just be those pieces of code that you need to wire all of this up and make it work. And you're going to find it's relatively simple and easy to write. So our first one here, our first diagram here, again, we're going to talk about the loosely coupled message bus here. We're going to show you the code that we used for GeoConfig here. We're then going to show you what we call our legacy SIM application that we wrote up. And then finally, we have an updater API that's a Spring Boot app as well. And we're going to demonstrate all of this to you of how the actual code that we wrote and implemented here. So the first thing we're going to look at is the GeoConfig piece right here. So Zach?
Yeah, so as we move to microservices, and this application could live on a Pivotal platform, it could live on Kubernetes, and in our case, it's Pivotal platform. So if we go back to our favorite corporation, the Acme Corporation, they've decided that they have a new customer service that they want to implement. And that customer data originally lived in legacy. Now, we could do that for a variety of different reasons, but one of the main reasons that we find is that that customer data is needed by the other services within the mesh at the time. And we like caching. So we're going to go ahead and cache at that microservice level. So here we kind of leverage, and as we're at a Spring conference, we leverage three main projects. So Spring Boot, Spring Data, as well as Spring Cloud Stream, which we'll see in a minute. The first one, and I don't know if anybody had a chance to join John Blum's talk yesterday about Spring Gemfire Starter and Spring Data Gemfire, but that's what we're doing right here. So in order to get a connection to our cache, it takes these 5 simple annotations. It's that simple. The first is going to be enable entity-defined regions, which is basically our method of storage within Geode. It can be analogous to a table if you're from a relational world. And then all I have to define is my model. So if I have a customer Pojo object within my application, I can just have that annotated as a region, and that bucket of storage is made for me. The next one is going to be @enable Gemfire repositories. This is domain-driven design concept. This also allows us to abstract much of the boilerplate code from the technology that we're using. Back to what I mentioned before, more in the value, less in the details in the technology that we're using. Able to do this, it's a standard CRUD repository that's very similar to using Spring Data JDBC or JPA, which allows us to switch that back and forth depending on whatever our use case is. The next one is just @enable security. That allows us to get the credentials needed to talk to our cache. If we're using Pivotal platform, the bind service, that works magically out of the box. We get not only the connection URL to our locator service, which there's some other talks here at Spring that can explain a little bit more in detail what that is, but also our credentials. And then our favorite, Spring configuration. All right.
So the next area we'll be talking about is the actual legacy SIM application. Rather than reading from an actual database here, we did create a file. We created a lot of sample data, random data that we read from, and that actually feeds into our legacy SIM app here that we use to feed over to here.
Yeah, so this is our favorite. So for the sake of our demo, we're using a file as our legacy system. So that file is going to live off in some legacy system. We're going to read it in to this application infrastructure and cache it so that every other application can use it within Pivotal platform. To do that, we need a message bus. We used RabbitMQ for our example. The main key features here that we're showcasing is Spring Cloud Stream and mostly the @enable binding. So that provides us an easy way to read and write from the message queues without having to write a lot of the standard message boilerplate code. And we showcase 2 here. One is the source, which reads from a system, and it comes with a whole bunch of starters out of the box, but we wrote an actual file one so that we could read our file. And then it writes to the message bus, where the next piece picks it up.
So the last piece we're going to talk about is our actual updater API right here.
As I mentioned before, we have the @enable binding for the sync. This is read from a message bus or queue of some point, and then handle the message. Nice and simple. Now, we could have had this write directly into our system of record or our cache within the platform. But as we mentioned before, we want to keep things as loosely coupled as possible. Now, we're able to leverage the actual customer microservice that we have now within the platform. And as most microservices or many microservices, we may have a REST API that may have some CRUD operations, create customer, delete customer, update customer. So we're going to call those directly from within the Spring Cloud Stream app so we can keep it as loosely coupled as possible. And this way, as we move forward, it's much easier to take this part out once we move totally to cloud data. So we see here, once we have the file, excuse me, once we have the file, we write it to the message bus. We're going to handle it here, and it's going to call our customer service API, which we talked about previously, to cache that data and make it available.
So now we're going to go into the demo. So Zach.
All right, so for the demo portion of this presentation, let's remember back to the Acme Corporation. The Acme Corporation had some customer data within the legacy system that some of the new applications that they have started to push to the cloud also needed to use. For that, they've decided, let's go ahead and build a customer service microservice that can service those other requests from within the cloud service mesh. Since that is usually highly transactional and we need low latency in order to grab the customer data, we've backed this by a cache, namely Pivotal Cloud Cache, as we are running on the Pivotal platform for this app. So to dive into this is our customer service API. It's a very simple, straightforward REST API, something that we would similarly see for a domain-driven service. It comes with a customer controller. It has two methods within that, a create and then a find by customer ID. So let's go ahead and build one of these out so that we can see what a standard operating model for this customer service would be. So as we can see, we have our customer domain object. It comes with a name and age, phone number, address, and phone number. So let's go ahead and create one of these. So for my customer, I'm going to go ahead and create myself. So we have Zach Hansen. We can put in an age. We can put in an address. And a phone number. And then we can go ahead and execute this REST command and save our service. So we can see that we got a 200. My new customer has been saved. And then let's go ahead and just retrieve that while we're here so that we can make sure that everything's working. So this is pretty straightforward. I pass in an ID. I ID'd off of name. We can see that we get a 200 and I'm able to retrieve my customer record back from this customer microservice. All right, so let's talk about how we are going to now leverage that legacy data within this new customer microservice. So in order to do that, we have a couple of applications that we need to start up. So this is the Pivotal Platform Apps Manager. We have our customer service application running. As we mentioned previously, in some of the wiring steps, we're going to create a loosely coupled message bus to bring the legacy data over to the new customer microservice. So the updater API, that sync application using Spring Cloud Stream that's going to read from the message bus, I went ahead and already started that for the sake of time. The one that we need to start, and it's going to do the majority of the work and lifting for this, is going to be the legacy simulator. So in order to simulate legacy applications here, we chose to actually run this within Pivotal Platform. This could also be running outside in your legacy environment. And our data is going to be sourced from a file. So let's go ahead and get this started while we're here. And while that's starting, all right, now as we wait for the legacy simulator application to start and actually start retrieving that data from that file and writing to the message bus, let's go ahead and talk about how we wire this up. So to do so, first off, we start with our services. So this is going to be the backbone of how we actually wire these applications together using Spring Cloud Stream. As we mentioned before, we're using RabbitMQ as that message bus. Now within that message bus, we actually can go to our management console here and see that we've created a S1P demo queue for this data exchange to occur on. And then as mentioned before, we also have one other service here in order to leverage that customer data within our customer service API, and that's going to be leveraged through a cache. So here we have our Pivotal Cloud Cache, and that's going to have one method of bucket. It's going to be our customer bucket, and actually we can see that the legacy simulator application has already started in loading our data. And yes, the legacy simulator application has fully started. We can see that it will then write to the updater API. So if we look at this real quick inside of its log messages, we should be able to see that we are updating our customer service. So as we can see that as we consume the message from the message bus, we are going to update our customer service with this specific customer. And finally, as we go back to our customer service API, and I lost my window, so let's go ahead and grab it again. And then we can go to our route, we can go to our API, which is via Swagger. We can see that we can grab all of our new customers. So to do so, let's go ahead and see what a new customer would look like. So to do so, we can use this management console provided by Pivotal Cloud Cache called Pulse. From within here, I can actually say select star from our unit of measure or our unit of storage, which is customer. And for now, I'm only going to limit it to 10. After I execute my query, I can see that I do have some new customers that have been created within this service. I'm going to go ahead and take Kelvin. So if I retrieve by customer ID, I should be able to get Kelvin. And I do. I can see that I retrieve Kelvin, and now this data is fully able to be leveraged within the new cloud native space. And it's also important to note here that as we move this data from legacy into the new cloud native infrastructure, we can also go in the reverse order as well. As services continue to use this new customer service, we can actually leverage some of the features of Pivotal Cloud Cache or of the message bus that we've created in itself in order to rewrite that data back to legacy so that we have that backwards compatibility for the applications that need it there as well. So just a quick summary of what we've shown today. We have this customer data represented by C1. That data is going to go ahead and move through the legacy simulator application. It's going to be loaded onto a message bus, which is then going to be read by the updater API. It's going to be passed into our new customer service API, which is going to include that GeoConfig to get the cloud cache connection, and then its final resting place is the cache.